So, good morning and welcome back everyone. Today is August 15, 2017, and it happens to be an Indian Independence Day, a national holiday here in India. And I thought of utilizing this time to record a new video on Oracle logging and tracing. I'm going to talk about how do we trace a particular service, a session, or for that matter, a particular module or an action. I'm also going to talk about how programmatically one could write to an alert log or generate their own trace files. And subsequently, since the log and the trace files are primarily raw in nature and it contains a lot of great details which people may not be interested looking into line by line, we'd look at how to format those trace files into a more readable, crisp report summarizing what has happened during the lifetime of that trace file. The core here is to understand why do we trace. We trace typically to find out what happens behind the scene when you run a SQL statement. Normally we do that to find out performance issues if any, or even to find out what all activities are happening in the background when you run a SQL statement, not just necessarily the performance issues. Now, things that I'm going to talk about in this session are about where can one find diagnostic files, how can one trace his own session using the Oracle event 10046, how can you trace your own session using the SQL trace command for your session, or for that matter tracing your session using DBMS Session package. There are multiple other utilities as well. I am also going to talk about what if somebody wants to trace a session using DBMS monitor package. There is a command tool which is called as the Aura debug utility. I am also going to talk about and show you a demo as well for each of these utilities. How one can use Aura debug utility to find out or generate a trace. Well, Aura debug is a large utility. It has variety of different options, but I'm going to limit my discussion only on to generating trace for a given session. Then I'm also going to talk about the other methods that are available for tracing, means apart from using 10046 SQL trace, DBMS session package, DBMS monitor, or for that matter Aura debug. There would be cases when you may want to enable tracing the moment a user logs in. So how to enable automatic tracing without without typing in commands explicitly for a given user login by enabling tracing via logon triggers in Oracle. I would subsequently then talk about what is the understanding behind a service, what service as a concept is, and how it helps in aggregating the performance statistics. Then I'm going to talk about implementing code instrumentation, which are some standard best practices for developers, whereby they can use DBMS application info package provided by Oracle can introduce then client identifier, module name, and action name during their code so that it becomes easy at a later date and time, and your $V session, or for that matter $V session long ops, can provide you more meaningful information in the relevant places instead of showing module name or action name as empty. Then we would also talk about what are the challenges in tracing, like what if I enable trace in a dedicated server configuration. And what if I enable a trace in a shared server configuration? In one case, you may get a single trace file for your activity, for your session, whereas in case of shared server model, you may have several scattered trace files. Now the challenge is, how do I put them together and create one consolidated trace file for my analysis? Then we are going to do some hands-on consolidating some trace files. When there are multiple scattered trace files for your activity, you are going to join them, combine them using the Oracle utility trc-sys, and subsequently I am going to talk about how do you read the raw trace file. Now this is not something that we do usually, but there's nothing wrong understanding the format of a raw trace file and read it through line by line to find out what all details typically Oracle puts into a raw trace file. Now in a general world, nobody is going to spend time on reading those raw trace files. Once the raw trace files are generated, probably you are going to transform them using tkprof, which is the transient kernel profiler, into more readable and a crisp report which summarizes the lines that you see in a larger raw trace files. And then I'm also going to walk you over like what is typically the format of the output generated by the tkprof report, or in the tkprof report, how do you read it, how do we interpret it. And subsequently I'm going to talk about an alternative to tkprof. tkprof has some challenges, uh, plus it only generates text files. They are not as in details probably as one could expect it to be. So I'm going to talk about an alternative to tkprof called as the Oracle Trace Analyzer utility. Using the Trace Analyzer utility, we are going to feed it with 10046 event related trace file, and this utility is going to generate an HTML based report for us with great amount of details into it. Typically this is an alternative, a better alternative to tkprof. And then I'm going to also walk you through, if someone wants to install a tkprof alternative, which is the trace file analyzer, then how do you install it, how do you deinstall it, or for that matter, how would one use the trace analyzer utility to analyze the raw trace files. So let's get started with our presentation. Wherever possible, my idea would be to show you a demo, and onto the second slide itself I will introduce you to my demo environment. I run Oracle 11.2040 database in a VirtualBox environment on top of my Mac, and I will use a sample demo environment for showing all these utilities that I'm going to walk you over throughout this session. Be patient, because I have done some customizations to simplify my life. Wherever possible, I'm going to introduce you to those customizations. Like there are customizations related to my Unix environment. I have created some shorthand scripts so that I don't have to type the lengthier Oracle commands. But wherever possible, I would try to make you more comfortable with the environment that I am demonstrating these scripts into and these techniques into. So I have my demo virtual machine up and running, and using my command prompt, I'm going to connect to my demo virtual machine. The IP address doesn't matter in my case, it is whatever you see it on the screen. And once I log in, I prefer to set the environment manually instead of sourcing it from the bash profile, because this is not the only machine I have. I have multiple other machines, and then if the environment gets sourced from the .bash profile without printing anything onto the screen, I typically find myself lost as to which machine I am onto, whatever it is, and probably there could be more than one databases, Oracle homes, environment settings. So I typically prefer to put all these things into a env file and manually source this env file, so I would know where exactly I begin. I will quickly walk you over my env file. The database that I'm going to use for this demonstration is going to be an 112040 database. The name of the database is PTDB, for performance tuning database. And as you could see on my screen, I have done standard variables like Oracle base, Oracle home, TNS admin, SQL path, and I have set my diagnostic trace. I have set my alert log location. This is only there for simplified movement from one directory to another. So the moment I want to jump to my alert log, I don't have to keep on typing the whole ADR path to my ADR home and subsequently into the trace directory and ultimately locating my alert log file. Now to simplify my life, I also created some Unix friendly aliases, command aliases like diag would directly take me to the diagnostic trace location. SQLD command would launch me SQL developer, and whenever I want to see alert log, it will show me last 40 lines of my alert log. And then I have created a simple script startup.sh which starts my environment, so I don't have to really go and start the listener, start the Oracle database instance. Like the moment I'm ready, I will say startup and it should start me my environment and I am ready to go. Now apart from this, I'm going to rely on a lot of scripts that I have developed over a period, and here are those scripts. Like throughout the demo I would be using these scripts to demonstrate various things, so that I don't spend more time on typing this, although I would be more than happy to open those scripts for you and show it to you. I have done some customizations in the way my glogin.sql script is, so that I don't have to type some SQL environment variables. Formatting aspects would be taken care by my script. And we are here, so you see right from the customization, like username at the DB and the date today, when it's an Indian Independence Day today, as I mentioned earlier. So we are here. So let's get started with the presentation. I'm here. I'm explaining you what diagnostic files are. So diagnostic files are files which are generated by the Oracle background processes, so that whenever you start troubleshooting a problem, the primary location where you should go and look for the troubleshooting related aspects, inputs for your troubleshooting, are the log and trace files. The instance parameter called as diagnostic dest is typically set to your Oracle base Unix environment variable. Now those who are Oracle DBS, they already know that during the installation of the Oracle RDBMS server software, it prompts you to specify the Oracle base and Oracle home. Now Oracle base is a top level directory, and somewhere under it you might see an Oracle home, which is the product directory where you might have installed the Oracle RDBMS server software. Now to support this, there is a parameter called as diagnostic dest, which is a initora parameter, and I log in as sysdba. I'm trying to show you the diagnostic dest parameter. So you see here, and if I try to match it to, it matches to my Oracle base by default, and this directory is what you specify during the installation. If you are not happy, you can always change this to something else, but ADR has to be adjusted accordingly. So your trace and log files generated by your background processes, or for that matter your server processes, are stored under the Oracle base, DAG, RDBMS, name of your database, name of your instance, and under the trace location. Now, going to this directory every time by typing such a long path is going to be troublesome one, especially when I'm recording a video. So what I have done, I have created an alias called as diag, which directly takes me to that location. So I don't have to necessarily type cd u002 app oracle diag rdbms ptdb and trace. I can simply say diag and it will take me to that location, where I could see there are many trace files. Although I cleaned up this location just prior to the start of this video session, there were even indeed hundreds of files lying there. I cleaned them up because I wanted to start afresh with this presentation. Now, all your diagnostic files, given that they are here, you also need to know that Oracle has introduced a facility called as automatic diagnostic repository, which is generally enabled. And how Oracle configures that ADR and what folders, what files it would place and where it would place, this information is available from a dynamic performance view called as $diag info. Now I'm going to show you by logging into SQL Plus my diag info, and probably you may not like the way it has been formatted, so let me make it more readable. So I'm formatting the column name, format is a 50, and possibly column value format a 70. And you see now this is the name, this is the value, it's coming from my diagnostic dates. It talks about whether or not diag ADR has been enabled. It's true. And my ADR base location, which is nothing but my Oracle base, which is pointed to by my init.aura parameter diagnostic_dest. And for every Oracle home that you have possibly, and every database that you have, there would be an ADR home. That ADR home would be under diag rdbms, name of the database, name of the instance. And further, for every ADR home, there would be trace, there would be alert, there would be incident dump directories, core dump directories, and you would have health monitor files. And for the current session, if I start doing some tracing, it also shows me my default trace file. So if I do not customize the name of my trace file and start enabling the trace now, then whatever is recorded as part of my trace enablement would go into this file. Now typically I don't prefer to use the generic names for the trace files because they are very generic. It talks about the name of the instance, underscore aura, underscore the PID of the server process which would do this tracing for me. And I typically prefer to customize the name. So from a very large diagnostic location, it becomes very easy if I put a naming pattern to it. Then using that name tag, I can quickly search through my trace file amongst a lot of other trace files that are possibly there. Although I have cleaned up this location here today, it won't be the case in real life. You would see possibly have hundreds and thousands of files lying there, and figuring out which one is yours is going to be a difficult task. So it always makes sense to give some custom tag to the trace file name once you are into some serious tracing. More on it at a later time. I will show you how to do that. So as I said, I have done some customization. I have diag command, which in my lab would take me directly to do the ADR home and trace location. Alert command in my lab would show me the last 40 lines of my alert log file. So every time I want to look into my alert log, I'm not going to go to that directory and open that file. I would simply say alert and it would print me It prints a reverse video effect, the name of my alert log file, and then it shows me last 40 lines of my alert log, especially when I'm into something and I would like to look into my alert log. Now quickly understand what's there in the diagnostic file, how the structure is. Here's a diagrammatic depiction of the directory structure and the hierarchy there. You have an ADR base, which I already said is Oracle base, which you provided at the time of the Oracle software installation. Under that there would be a diag folder, under which there would be a folder with the name RDBMS, since we are talking about the Oracle RDBMS server software. Under that you would have a folder with the DB unique name. Now DB unique name is another parameter in your parameter file, which by defaults to the name of the database or DB underscore name parameters value. Now within that there would be a case sensitive Oracle SID. SID is nothing but your Oracle system identifier, which typically is the name of your Oracle instance, and this is what is called as the ADR home for this particular database. Now under the ADR home you would have a whole lot of different subfolders. Alert, where your XML based alert log file is, and trace, where your text alert log file and background trace files would be. Now remember, this is the important location as far as this particular current discussion is concerned, because all our files, trace files, would ultimately be generated here. Now there are other folders also, but they are irrelevant for the current discussion. There is a core dump. Whenever the process terminates abnormally, it would generate a core dump. Those core dumps can later be analyzed or sent to Oracle support for further diagnostics if you are running into some serious trouble. There are incidents related files when you use ADRCI for packaging incidents and problem information. So when you open an Oracle ticket, those incidents can be classified here, and then as a incident bundle you can upload all the relevant input files so that Oracle can do better troubleshooting in lesser time once they get all the files that are required for troubleshooting or assisting you into your technical problem. Now have a look at this table and understand what used to be our previous conventions in the older version and what are the new equivalents. So these foreground process traces were earlier found into user dump dest, which was one of the initora parameters in the earlier version. We identify that today as ADR home and trace. Your background process trace files, which are both nowadays it's both background as well as user trace files, all of them are located again under ADR home trace. Earlier it used to be background dump dest. Your alert log for your instance earlier used to be under background dump dest. Again it is today in two formats. One is Oracle home alert. Here's the XML version of your alert log is, which is easy when it comes to writing automatic parsers, and the text version of your alert log is there in ADR home trace. Then your core dumps were earlier pointed to by a directory parameter called as core dump dest. Nowadays those core dumps would go under ADR home C dump folder. And then we have incident dumps. Earlier they were stored either in user dump dest or background dump dest. Now you have incident directories called as ADR home incident, and the incident directory followed by an N, a numeric incident number for that incidence. Now coming to the tracing, which is our main topic for the discussion. So imagine a case that you would like to enable a trace for your session. You are doing something important, really important, and you want to trace it to find out what happens behind the scene when Oracle executes it, execute this SQL statement. So here is the flow. Optionally, first set the trace file identifier to quickly identify your trace file. Otherwise it's very difficult if it's a generic name. Then identifying from the many generic files out there in the trace location, which one is yours is going to be a really difficult task. So I typically prefer to set an identifier which introduces a name tag into the name of the trace file. So here's the script that I'm going to run through. I would log in as Scott Tiger. I would set the trace file identifier to my name, and then I would check where my diagnostic file is getting generated. And once I know where my trace file is going to be generated, you can notice here that instead of using a generic name like ptdb underscore aura underscore pid.trc, now it has introduced my tag in the name of the trace file. Followed by, I'm going to enable 10046 event at a level 12. I would explain shortly what that level 12 means. So followed by the queries that I would like to be traced. I'm going to run just a samples query, which is a simple equi join onto emp and dept querying ename and dname. And once I'm done with all my SQL statements that I would like to trace, I'm going to disable the trace by saying alter session set events 10046 trace name context off. Now, if you see how I have enabled a trace, it is via alter session set events, and the event that I am setting here is 10046, and I am setting it at a level 10. Now these levels decide what degree of details are added into your trace files. Now higher the level, the more and more details would be dumped in your trace file. By default, 0 means no trace, which is as good as setting SQL trace off. 2 means equivalent to a regular trace. When somebody enables a SQL tracing, a very basic trace file would be generated. Then if you set this level to 4, it is same as 2, but with addition of bind variable values would be added to the trace file. Now in my query especially, I am not running any bind variables, but imagine a case that somebody runs a query with the bind variables, and the query talks about something like department number is equal to :1. Now we don't know what that :1 is unless we poke into and try to find out what the value was. So you can instruct Oracle to generate a trace, so that along with the trace it also dumps the value of the bind variable. And you can enable the trace level as 8, which is whatever you see in 4, plus in addition to that it would also dump all the wait events encountered when you were running your SQL statement. Now those who are into performance tuning, or they would like to understand like where my SQL statement is spending a lot of time, they would typically enable dumping of wait events into the trace file to find out where exactly during parsing, during execution, or during the fetch phase of SQL statement processing, where is my SQL statement spending a lot of time, and onto which particular wait event it is spending more time on. So those who are into serious performance tuning of a SQL statement, they would definitely need the wait events. Now when you club these bit or bit operators, you can club 8 plus 4 is equal to 12, which means into your SQL trace file, dump the value of the bind variables if bind variables were used, and also dump all the wait events encountered by your SQL statement when it was going from parse, execute to fetch. So I'm going to run through now to simplify my life and to stop me from or to prevent unwanted typing at the time of recording this video. I have created a sample script file here. I have example 10046.sql, and the contents of the SQL file are already shown here. I would also show you the SQL file. I'm going to my home directory into the scripts folder just to show you that I'm indeed using the same thing that you are seeing there. Where in my home directory, in scripts, I have an example script here. So you can see whatever I have shown there, pretty much the same thing I'm going to run through. There are certain formatting aspects to see what my trace file name is like, and then I'm going to set some event, and then I'm going to run through by enabling the trace at level 12 followed by my query, and then subsequently turning it off. So let's do it one by one. Here I am into SQL plus, got tiger, and once I'm there, I'm going to copy paste it. So this is my diagnostic location, and if you want, you can query more. Possibly you can query prior to setting the name to see what's the default name for the trace file. Now this makes it very difficult to identify your trace file, so I always prefer, as I said, to set a trace file identifier. So I set some trace file identifier followed by the same query again to see what is the change now. And the change now is, in the name of my default trace file there would be a tag which I have set as part of the trace file identifier, making it easy to spot my file amongst the many different files that I have. And I'm going to now enable trace followed by a query, and I will quickly disable it even for that matter. So I have already enabled a trace, I ran a query, I disabled the trace. Now comes the part of locating your trace file. Now you could see this is the trace file, and it very well contains my trace file identifier. I'm not going to spend more time immediately now on understanding what's there in the trace file, but just to show you quickly that this is indeed the trace file of whatever I have just done now. Now in many places you would see that there is no module name. The module name is SQL star plus, which because I use SQL star plus tool for it. Client ID is missing, action name is missing. Now this is where the code instrumentation comes handy for the developers. Now it doesn't tells me what precisely. Now I know here that I was using SQL star plus, but imagine in a complex world when there are many different applications connecting to your database and you would like to generate a trace file, you possibly generated one or many. Now you don't know which trace file is for which module or for what action or because of which client's connection. Now this is where the code instrumentation I like the most, and as a serious developer you should inculcate that habit of doing proper code instrumentation by using DBMS application info package, which I am going to describe in one of the slides along with the example. So once I have this trace file, well, I'm not going to do anything with the trace file at the moment. This was just to show how to enable the trace for your session using the 10046. Later sometime in the same presentation, I am going to walk you through the raw trace file, how to read it, what all things are there into the raw trace file. Further, I am also going to explain how to use tkprof, or for that matter trace analyzer, to transform that raw trace file into a more meaningful report which is more readable compared to this raw text file. Now people might wonder that I just ran one single statement, and see the size of this raw trace file is close to 50 plus KB. And if I count the lines, you see there are 1000 odd lines into this file for my single statement. And here's my statement that I ran earlier, and one can quickly read it out that there was a parse, there was execute, and there were wait events related to that, and possibly after that there was a fetch, so on and so forth, and there were some stat related wait events. This is what is that trace file generated by your 10046 trace event. I'm going to show you some alternate methods as well. Now, an alternate to 10046 is SQL trace. So one can enable a SQL trace for his own session. First, you need to obtain your SID. If you want to obtain your SID, you can say select SID from $mystat where row num is equal to 1. Especially when you are connecting, let's say when there are many people connected using Scott Tiger. Now with the username Scott, possibly you don't know out of those many sessions which are there, which one is your session. So one can say select SID from $mystat where row num is equal to 1, and this would give me the SID of my session, which is 141 in this case. Now in the outright here, because querying certain views via SQL star plus, especially the ones which are having many columns, it becomes very difficult to read them through. So I'm going to set my environment and launch SQL developer instead by my command alias SQL D. And once connected to the database, I am going to verify whether or not the number that I got there is a correct number. Now to eliminate odd things out, I logged out from the other Scott session that I just used for my demonstration for obtaining the trace of 10046. Here I am connecting to my database, and I like SQL Developer for one reason, that my columns don't get scrambled up and the output doesn't get messy. So I am trying to obtain details about the Scott session, although my interest is only on to finding SID. And one could see the SID for the only Scott session that you have active at this moment is 141, which is reported to you by the command select SID from $mystat where row num is equal to 1. This is handy when especially you want to know the session identifier for your current session. Now to be able to query mystat, Scott should be granted. If you want, Scott should be able to query $mystat, then the user must be granted select privilege on v underscore $mystat. Otherwise it will report an error saying the table or view possibly does not exist. So prior to typing this, ensure that the DBA has granted you select privilege on $mystat. Now once you know the session ID of a given session, one can also find the name of the trace file for that particular session by running a command p.trace file name from $session and club it with $process, and the process address should match to the process address in $session and across session and $process. So you can obtain the name of the trace file. There's an alternate way. Although I have given earlier that from $diag info itself one can query it, there are alternate methods of finding out where your trace file is getting generated. Often I have seen people struggling finding out the relevant trace files from hundreds and thousands of the trace files that are there in the ADR trace location. Now things are much better starting from 12.2. Starting from 12.2, one can query the name of the trace file and the contents even of that trace file using select trace file name from $diag trace file where connection ID is equal to whatever is your connection ID. The select payload is nothing but the contents of your trace file. You can directly query it using a SQL statement starting from 12.2, meaning one need not go to the file, look at that file and then copy that file to read it through. One can type directly SQL statement starting from 12.2 to query the contents of your trace file. So here we are saying select payload from $diag trace file contents, where name of the trace file is put in the name of the trace file and order by line numbers. So all those lines in your trace file would be reported as if it's data coming out of the table, although it's a dynamic performance view. Now in this particular case, I'm going to show you how to enable SQL trace for your session using SQL underscore trace session level parameter adjustment example. So I'm going to log on through Scott. Then I'm going to enable again a SQL trace identifier, trace file identifier. So I have put in a different name this time. Select name value from diaginfo to find out what's going to be the name of my trace file. And then I'm going to simply say alter session set SQL trace is equal to true, followed by the same query again, and followed by disabling the trace once I am done. I already have a file created for this example -sequels trace.sql. So I'm going to show you in my scripts. My file name is this. I'm going to open it. So nothing great, whatever you see on the slide, pretty much the same thing. I'm going to log on. I'm going to put a trace file identifier. I'm going to find out what's going to be the name of my trace file, followed by enabling the trace, followed by my query, and followed by disabling the trace. So the name of the file is example-SQL trace.sql. So I ran it from the file itself, so one can see I ran example SQL trace, so session was altered, name of my file was printed, I enabled the trace, the session was altered, followed by my query, and then subsequently once done I disabled my trace for the session. Now here's the file that I got. Again you would see that a trace file quite similar to what I earlier obtained using by setting event 10046. Trace file similar to that has been obtained, but both these files, the one that I have shown you earlier and the one that you are seeing now, are raw in nature, means one would have to go through a whole lot of details to understand what all things are mentioned here. But yes, you managed to still obtain a trace file. What to do with these trace files, as I said, we'll see later. I'm moving on to DBMS Session, which is a package available into your Oracle database. How to use set SQL trace procedure in that package to enable the tracing in a given session. Again, we begin with the same basics again here. Optionally, you might want to set the trace file identifier to quickly identify your trace file. You might want to query the name of that trace file from $diaginfo to know exactly what trace file name is, and then you would like to enable in your own session uh, tracing before you do your activities. So using DBMS session.set SQL trace, you would enable that, followed by you might want to run some SQL statements, and once all those SQL statements which you wanted to trace are executed, you would like to disable the trace again. So unnecessarily you don't want that trace to put an extra burden on your Oracle database server. So I'm going to run through this example now. I'm going to run through an example -dbms session.sql. The contents of this text file are: first I'm setting a trace file identifier. I'm identifying what my trace file is going to be like, and I'm going to enable SQL trace by using set SQL trace and putting a boolean value against the parameter of set SQL trace is equal to true, followed by my query that I would like to trace, and once I am done I'm going to disable it. Let's have a look at the file first. So this is the one example hyphen DBMS hyphen session, pretty much whatever I have shown you on the slide. I'm going to log in and I'm going to run through example DBMS hyphen session. Again, nothing different, whatever it has done, it has printed you. And here you get to see the name of the trace file that you have here. And again, like previous two examples, you got a raw trace file using DBMS session on the similar lines. Again, as I said, I'm not going to spend time on to understanding the trace file. Let's move on and find out some other interesting methods of enabling trace. Now there is a package in the Oracle database called as DBMS Monitor, which allows you to trace not just your session but also someone else's session. Now you can enable tracing using DBMS Monitor for your own session or for a particular other user session which is identified using SID and serial hash, which is a unique combination for every person who is connected to your Oracle database instance. Or you can also identify a particular session by looking at the client identifier, and then once you look at a particular client identifier, you may want to enable the tracing for a particular identifier. I will show you probably at a later time how to set the client identifier using DBMS session.set client identifier, if not in this example. And then I'm going to show you how one can enable tracing of an entire service or for a particular module or for a particular action within that module. Now those who are not sure about what is a service, what is a module, what is an action, we are going to run through a couple of slides again, where I would explain what exactly is a service, how one could use DBMS application info .set module, or for that matter DBMS application info .set action for setting the modules and actions respectively in the coding. Now these are some of the best development practices developers should follow, that whenever they connect to the Oracle database for doing something, they should identify their module, they should identify their action. Now this makes life a lot more easier for later problem diagnostics, for performance diagnostics, and it makes the view $V session, or for that matter $V session long ops, a lot more readable. Otherwise I have seen developers, they just connect to the Oracle database and they are directly to the business. They don't like to set the module name, set the action name, set for that matter the client identifier. Now imagine a case that there are a whole lot of columns in $V session and all that you get to know is SID, serial hash and username. And many of the times, if especially the application users are connecting using the same user ID to the same schema, having only username, SID and serial hash alone would be of no use when it comes to performance diagnostics. So a good developer, I reiterate, would always like to make use of DBMS application info for code instrumentation, and he would use set module, set action, set client identifier uh, as a best practices while coding. Now what I'm going to run through is what if I would like to trace my own session using DBMS Monitor. So as a Scott, you log in and you run DBMS Monitor .set trace enable. Then once it is enabled, what exactly you would like to enable is the defaults get enabled. Now in this case I would like to enable the wait events capture, as well as capturing the bind variables if any, values of the bind variables if any, and followed by the SQL statements that you would like to run, which I have not demonstrated here though. and you would like to at the end of it disable it by saying session trace disable. Now let's look into our file to get idea about it. I am here, I am into DBMS monitor. So ideally, once you enable, you would like to run some SQL statements here. That's what is the purpose why you have enabled the SQL trace. So you enable SQL trace, you run SQL statements, and then you disable it once it's no longer required. Now this is to enable tracing in your own session. Not to mention that you must have execute permissions onto the DBMS monitor package for whatever user who wants to enable it in his own session. Let's try to run through uh, with the same SQL statement that we ran earlier. This one here. So what I'm going to do, I would log in as Scott, I would enable DBMS monitor. Now I'm not going to again add a trace file identifier, enough of it, I already talked about it. Just in case if you want, you can copy this line also to set your own SQL file identifier for the session. And this time I will call it as DBMS monitor. And once I am ready, I would enable it. I'm logging in as Scott Tiger here, and as you see, it says DBMS monitor must be declared, which apparently means we probably do not have uh, uh, execute privilege on this particular package. Let me try to do this one more time by saying grant execute on DBMS monitor to Scott, and then connecting in back as Scott, and this time it worked. I go to diag location, and this is my trace file. Possibly this is the one. Any of the two possibly could be the latest one. There are high chances that the latest one is the one that I am using now. So you can open, and again it's like a raw trace file. Now you might see a varying degree of details being dumped into the file, but nonetheless I would touch base upon again to understand what those trace files contain, so on and so forth. Now when it comes to tracing some other user session using SID and serial hash, going back to my presentation, as a DBA you can say DBMS monitor dot session trace enable, and you can provide the arguments as the SID and the serial hash. Now your SID and serial hash are always going to be unique. Now you know that I have two different sessions running as Scott. I could still say select username, SID, serial hash. You may want to include module, you may want to include action, you may want to include client identifier, you may want to include service from $V session. I possibly have not given the correct name for that column. It may be service name. I am checking the column names from $V session, and the name of the column is service name. And once done, I run it here, and I do not see any of the sessions running now. Did I exit from all the sessions? Yeah, I did. So when you have more than one SQL sessions, I'm logging in here, SQL plus Tiger. and then I use SQL D. I'm logging in. I accidentally killed my own SQL developer session by pressing Ctrl C. I'm relaunching it, and sorry for that. So I connect back in, and here I would like to put in select username SID serial hash, probably service name, module, action, client identifier from $session where username is Scott. Now one could make it out that there are two active sessions from Scott. One is for the SID 13 and another is for 139. Since both the Scott's user sessions were established by passing the listener, they are called as bequet connections in DBA terminology. That's why the service name is showing as sys$users. If I would have connected via the listener, you would have seen a proper name of my service, which is PTDB. Module name is SQL star plus, and this is what I was referring to. Normally developers would, when they write custom code, they would not put any module name, any action name, any client identifier. Now you tell me which Scott session is which of the two. Now just looking at username, SID, serial hash and the service name, nobody would be able to distinguish between the Scott session number 1 and Scott session number 2 unless you put some meaningful information in service name, not service name, in module, in action and in client identifier. Now this could have been made a lot easier by adding set identifier procedure, by using set identifier. Out of these two, if I would have used execute DBMS monitor dot set client identifier white Scott, or let's say white, I possibly I'm going back to my presentation to see it's a set identifier, not client identifier. Did I mess with something? I'm checking my DBMS monitor, package description, and I'm interested in looking at what is the name of the procedure which sets the client identifier. I don't see one here. Oh, looks like I'm querying a wrong package, sorry. It should have been not DBMS monitor, but it should have been DBMS session. So to identify, I'm saying execute DBMS session dot set identifier, and this one is white and the other one is black. And when I query them from here, now at least you come to know which session is which. Simply by not putting module, action or client identifier, it makes it very difficult to diagnose the performance, because out of the possibly you may have hundreds sessions from the same user, and out of which you want to possibly troubleshoot only one of it. Now in the absence of module name, action name or client identifier, DBA's life is very difficult. You can't identify which of those 100 sessions that you have, which one is the one that you would like to diagnose by enabling a trace. But if somebody would have put an appropriate name for module, action or client identifier, it becomes very easy to enable a trace on the basis of any one of these attributes. How to do that I will show you. But before I go there, let's understand that since both the Scott users were connected by passing the listener. That's why the service name that they by default get connected to is $6 users. Instead, if I log out from one of it and I connect by saying ptdb, which is my TNS entry, and I would run like this time as a red Scott, just a client identifier for my understanding. So you see here, now the moment you connected via the listener using a TNS entry, you are no longer connected to the default service called as $6 users. You are instead connected to a service name ptdb. Anyways, my point still remains the same, that as a good development practice, ensure that you put in a proper module name, proper action, and a proper client identifier, because troubleshooting in the absence of these valuable inputs, troubleshooting a particular session, tracing a particular session is very difficult. You might probably end up tracing 99 wrong sessions to enable a trace for one right session if there were 100 Scott active sessions without module and action and a client identifier. So I said use DBMS session.set identifier for setting the client identifier, and then one can just enable trace for that particular client identifier. I would have said execute DBMS monitor dot client ID trace enable client ID is equal to red, black, white, whatever we said, and whether or not you would like to capture the wait events, bind values. Let's do that. Let's enable trace for one of our sessions using DBMS monitor and client ID trace enable. So I am back here. In my case, as a sysdba, I'm going to enable it for red. So although here's my red session, I can log on to any other session as sysdba and I can enable it saying wherever the client identifier is red, I would like to trace it, and I would like to trace it further by enabling waits and dumping of bind variable values. And as that user, I would simply run a couple of statements. So here is that user. He is unaware that somebody is tracing his session. He is doing his work as usual. He doesn't gets to know whether or not the trace is enabled. Somebody is already tracing his session using the client identifier. And once that is done and you would like to disable it, you can say execute DBMS monitor client ID trace disable followed by whatever you enabled it for with the client identification name as red in my case. So once that's done, I can go to the diag location. Now this is where I was coming to. Now it's very difficult for you to find out which of the trace files, because the names are now the default ones, because I didn't deliberately use trace file identifier in this case. And now this is the raw trace of my session. Now I didn't enable it, somebody enabled it. Looking at my client identifier, somebody enabled a trace for my session. So using DBMS monitor on the basis of client identifier, then you can enable trace for other sessions depending upon the service name column value, depending upon the module name, depending upon the action name. All of it I have already shown you in the $v session. Like here, if somebody wanted to only enable it for a given service ptdb but not $6 users, it's possible using DBMS monitor. If somebody wanted to enable it only for a service named ptdb with a module as SQL star plus, but module not as SQL developer. One could have enabled it. One could have enabled it for a given service, a given module, and a given action name if a developer would have added in his code instrumentation some action. So here are a couple of examples where we are using DBMS monitor dot serve mod action trace enable, and here we have just mentioned the name of the service. Here we have enabled mentioned the name of the service, further filtered it on the basis of name of the module, and further filtered it on the basis of action name if any. Here we are enabling it for the service named ERP, module name addEMP, action name as insert, and we want to further mention that I would like to capture the wait events, and I want to like to capture the value of the bind variables in the trace file. And once all of it is done, you would run SQL statements. Once all those SQL statements are run, you would like to disable it. Again, we use serve mod act trace disable, and whatever you enabled it earlier for, go and disable it. Now, the interesting part of DBMS Monitor is the DBMS Monitor package also allows you a procedure called as database trace enable. I'm going to show you here. I am saying DBMS Monitor, and I directly jump onto a procedure named DBMS trace database trace enable and database trace disable. If you see the input that it expects it to be, like whether or not you would like to capture wait events, true or false, a boolean parameter, whether or not you would like to capture the value of the bind variables, name of a specific instance if any, for which instance. Now this instance name would only be required in case of real application cluster, when your database has more than one instances. Otherwise, if you would like to only enable it for all the instances in general, you can skip this parameter. Now doing this means using DBMS trace enable would trace all the sessions of your database. So here I'm not restricting it for a given session, I'm not restricting it for a given service, I'm not restricting it for a given module, I'm not restricting it for a given client identifier, I'm not restricting it only for a given action, but pretty much anybody who connects to your database, if you'd like to trace all those who are connected to the database, you can enable it. We don't do this in general. Database trace enable, and then once you are happy that all of them are traced, you can disable it, because it would put a lot of burden on your database, because pretty much everything gets recorded in the trace files. You might quickly end up exhausting your disk space, because all your disk space would get ultimately consumed by your trace files. So quickly disable it once you have tried it. The point I wanted to drive home is, apart from whatever methods I have shown here, there is also a method which can enable enable all the traces to be enabled at a DB level using DBMS monitor package. Then you have the Aura debug command. Aura debug is a support tool, but the limitation of this tool is it's only a DBA's tool. It comes from a DBA's toolkit, because it would require you to log in with sysdba privileges, without which you can't run Aura debug as. But in general, Aura debug is Aura debug can do a lot of things, but I'm going to restrict my talk only for enabling trace for a given particular session. But it can dump the SGA, it can examine the value of a variable in memory, or dump a value of a variable in memory. You can use it to set events in a given process. You can use it for doing a instance hang analysis. Whenever an instance gets hanged, this used to happen some time back. I have in fact encountered many such situations in real application clustered environments, where in 10G the instance, because of some strange wait events, I still remember the name of that wait event, used to be like cursor pins wait on X. used to go in a hang state where it would eventually die, but it won't terminate. The instance would still be up and running, but it's almost in a frozen state. It would go in a frozen state, and then Oracle would typically ask you to do a hang analysis. So we used to log in with as sysdb and then use ora debug to perform hang analysis by doing ora debug hang analyze command. You can use ora debug uh, to to generate a trace file on the basis of session ID, the process ID, the OS process ID, or the Oracle specific process ID. So one can log in as sysdb and one can debug the current session by saying ora debug set my PID, and you can do it for someone else provided you should know the OS process which you would like to uh, enable a trace for. So you can say ora debug set OS PID. Now as you can see, this is a OS PID which you can see at a Linux level, and then one can use ora debug session with the specified Oracle process ID, which is the the PID column in your $V process. By ora debug set ora PID whatsoever, and one can also further say Oracle event ora debug event 10046 trace name context forever and whatever desired level you want. Now if you want to see what trace file got generated, one can say ora debug trace file name. It will print you the name of the trace file, and once it's done you should ideally turn off the tracing by saying ora debug event 10046 trace name context off. So but the limitation, as I said, it's a command from the DBA toolkit, which means you won't be able to run it as a normal user. You need to log in, establish a session with sysdba privileges, and only then you would be able to run ora debug. Let's try to run through an ora debug command as well. I'm going to examples, opening an ora debug related file. So I'm going to trace my own session as sysdb. And what I don't know is here I should start tracing. I don't know what's going to be the name of my trace file, so I will find out that first. I don't want to mess up with the many files that are there. So you can see this is going to be the name of my trace file. And since I am a sysdb, I can pretty much query anything. So I can say select ename comma dname from empe comma dptd, where e dot dptno is equal to d dot dptno. And I should have qualified it because those are not my tables. And once I am done, I should ideally turn off the tracing, and then I go to the diag location to find out what was the name. It was ptdb ora 4934.trc, and this is my file. So you could see again a raw trace file generated for my query. You can make it out from here, parsing in cursor so and so. The SQL statement is the one that I ran through, like scott.dpt, scott.emp, a simple statement. It would print you parse, execute, wait, fetch, and close, stat, whatever is there in the raw trace file. Moving on to the next discussion, which is tracing session using other methods. So there are other methods to enable trace as well. One can create the DBMS support package by running a script called as Oracle Home RDBMS admin DBMS supp.sql, and then one can make use of DBMS support package.start trace by again specifying waits and binds true or false to enable it in your own session. Or you may want to do it for someone else, provided you should know the SID and the serial hash for that session. So one can use DBMS support.start trace in session, SID is equal to something, serial hash is equal to something, waits as true, binds as false, and once it's no longer required, you might say stop trace in session, again specify the same parameters. So these two examples, one of it is DBMS support package start trace to trace your own session, and this example again using the DBMS support dot start trace in session to enable trace in someone else's session. Now by default in an Oracle database, this package DBMS support would be missing, means you won't have it by default in your database. To create the package, you will have to run through Oracle Home RDBMS admin DBMS support.sql, only then you would be able to use it. Now apart from DBMS support, you also have DBMS system. Now to enable disable trace for a particular session using DBMS system, one can say DBMS system.set SQL trace in session followed by SID serial hash and to enable SQL trace as true. Once followed by your SQL statements that you would like to run through, or whosoever is running, he would anyways be running his job. And then once you have opt a handsome amount of trace and you no longer want to have it enabled, you can disable it by running through execute DBMS system.set SQL trace in session, SID, serial hash, and turn it off. So that was all about the different ways and means of putting or generating trace file, enabling trace file for yourself or someone else on the basis of SID serial hash, on the basis of service name, on the basis of module, on the basis of action, on the basis of client identifier. Now something really interesting. Now what if programmatically a developer wants to write something into the alert.log file? Now there is a package, as we said, DBMS system. It has a method called as ksdwrt. Now this is quite a weird name, but that's because Oracle never documented it for general public use purpose. So you can run through execute dbms underscore system dot ksdwrt. The arguments are n, which is a numeric argument. Now when you put the value of n as 1, it means write only to a trace file. When you put the value of n as 2, which means write to only alert log, and when you put the value as 3, it means write to both a trace file as well as into alert log. Let's run through a sample example -custom alert.sql. Now I'm going to run by putting a value as only 2. I have put in some weird message like put 2 only into alert log and log your alertness here is the message that I am printing. Now as a developer, whosoever is running need to incorporate this into his code, and then I would like to see my alert. As you know, I have a shortcut created, alias created for it, alert. You can see the message is coming from my alert log and log your alertness here. So programmatically it's possible to log messages into the alert log file if you are doing some serious development. Consider this as one of the options of recording messages for DBA's understanding into the alert log. If I would have changed that argument to 3, then it would have also created a trace file for it. So I'm copying this over. Instead of 2, I'm typing red, blue, green, and then once I go there I say grep-l red, blue, green, and from all the files you can see one of the message got recorded in alert log, and a similar message we have got recorded into the trace file. My point is, as good development practices, if you are into some serious log and trace generation, do consider that there are ways and means available using which you can write application messages into the alert log, if especially you want to make your DBA aware of certain monitoring, certain situations. Then do log them, because DBA's favorite file to start diagnostic is alert log and trace file. Now there sometimes you may want to automatically enable tracing for a given user. Means the moment I want it like this: no matter who connects in, from what application, with what action, with what module name, with what service name, if the name of the connected user happens to be Scott, I would promptly like to enable tracing for his session. So in that case, you certainly don't want a DBA to do a babysitting job, that every time there's a new session being opened, a DBA would find out who is connected, and if it happens to be Scott, he would use any of my previous methods like DBMS Session, DBMS Monitor, DBMS System, DBMS Support, or using the trace event 10046 to manually go and type the command to enable session tracing. Instead, in such cases, it makes sense that you write a trigger, after logon trigger, for that particular user. So I am creating a trigger name always trace Scott after logon on database when the username is like Scott. I have not kept it open for all the users. I only wanted to trace every time whosoever connects in as Scott, and whatever he does, he or she does, once connected, I would like to pretty much enable a trace for each of those connected sessions. So I have generated a file name tag, which is I just, because now putting a common tag for Scott for everyone may not make sense. So what I have just done, I have obtained a file name tag by concatenating name of the user Scott with the current date and time. So my trace file names get the date as well as the Scott as identifier. So if there are 10 people connecting from 10 different applications, from 10 different services, from 10 different modules, having some different action and client identifier set, I don't care about what they are doing, what their trace file name should be. I have obtained a generic method of generating a trace file names by concatenating the name and with the timestamp, which I generated in DDMONYYYY, 24-hour clock with minutes and seconds embedded into it. And then I'm simply setting this file name tag as a trace file identifier. Now execute immediate is a way to run DDLs via your PL SQL code. So using execute immediate, one can write the DDL commands in the PL SQL code. So I'm going to show you this as an example after login, and don't forget to drop the trigger once the purpose is saved, because otherwise if there are hundreds of people connecting in through Scott daily, you would have possibly hundreds of trace file runnings into thousands of lines, and you would create more trouble than help for DBAs, because DBAs now daily would have to be there on their toes to clean up the disk space. Otherwise the disk space quickly could get exhausted because of huge number of trace files getting generated. So I'm going to run through example after login.sql. And this is pretty much the same code that I'm going to run through now as sys. And before I do that, I would ensure all my Scott sessions are terminated. So I don't want to poison my observation. And then only as a sysdba, I would like to create this trigger. Once the trigger is created, we'll go to the diag location, and for every time whenever Scott user connects, we'll see what files are getting generated. Now Once the trigger is there, here connects my first Scott user and he is unaware somebody is stressing him. He said select star from EMP and his job is done. He logs out. Here comes another Scott's user session. He says he is unaware of the fact that somebody is tracing his session. He said select star from DEPT and unaware he logs out, and here for my DBA are the trace files. So different trace files for different sessions created via after logon trigger. Necessary code has been built into the trigger. If I open is one of the trace files, no different than what we have seen earlier. A raw trace file for whatever we are doing. So nothing different. Well, that's said and done. Very important thing for me, without fail, I should drop the trigger. Otherwise, it's going to create a lot of problems for me to clean up these files, trace files every now and then. So I drop the trigger, so no longer we should see trace files getting generated for the user Scott. Now here, now that I have already talked about what are the different methods of enabling trace and everything, I would like to stop here as part 1, and in the part 2 discussion I would like to take it from here. What is a service, and I would eventually talk about how, as a good programming practices, developers should do code instrumentation using DBMS application info to introduce proper module names, service name, module name, action name. Then the challenges with tracing, like what if there are multiple trace files getting generated, how to use trace session utilities to combine multiple trace files into single trace file. And then I will also run through an exhaustive session on how to read the raw trace file, what all things one must be aware of a raw trace file. Then I'm going to run through that those who are faint-hearted, those who don't want to read the raw trace file, for such people and for many other intelligent people, they would never read a raw file, although they may not be faint-hearted. But one would like to always generate a more readable, crisp report out of it using tkprof. So how to run tkprof against a raw trace file, what is the meaning, what are the parameters, how to read the output of tkprof. Then instead of using tkprof, how one can make use of trace analyzer, trca utility, how trca works with one trace file, with multiple trace files, how to install trace file analyzer, how to drop it if it is no longer required, how to run and obtain HTML reports. And that's where I would conclude in part 2.